Hello and welcome to Roberts Tech. This is part 2 of our chassis build, and I want to show you how things are coming along with the wiring. I've drilled all the holes and everything's mounted in the power bay. Also have my processor boards mounted. So things are working out really well. I had laid these boards out so that I had basically paths for my wiring, and it has worked out well. As you can see, all the wiring gets to all the different boards without crossing over any of the boards, and I didn't run under any of the boards either. I want to be sure that I can get to the wiring easily if I have to. I also had to drill some wire ports so that wires could be put through the side of the chassis as well. Show the one on this side. So that was a hole I actually had to drill, and I put a plastic sleeve in there to protect the wire from the metal. So, and as I said I was going to do in part 1, I did cheat here, and I drilled a hole in the side here for this power wiring to go through to the bottom where I have all of my power wiring, and I'll show you that down in this pod. So here we have the power wiring, which comes from the battery, and I've split the battery into 3 different taps, so I have plenty of connections there for all my different components that need the raw 12 volts from the battery. Of course, it goes through the switch and well, it goes through the fuse first and then into the switch. And I want to show you this fuse. This is an automotive type fuse, but it works just fine for this application. I've got a 7.5 amp standard ATC type fuse, and tucks in nicely in this little holder under here, and there you go. You have a fuse for your battery, a switch to turn things on and off, and a tap to bring all the voltages out to where you need them. Now, one more thing I have added is a charge port, charge connector here. Now, the charge port is for my little battery charger that I bought for a sealed lead acid battery. And what I've done is I've replaced the little clips that this came with to a Anderson power pole type connector, and that allows me to just plug right in when I want to charge the battery. So that just plugs in right here. And one thing to note is that this bypasses the switch through the fuse straight into the battery. So even if the power switch is off, whenever I plug in my charger, I know it's charging the battery, whether the switch is on or off. So that is the 12 volt power section. So back over here, of course is where 12 volts comes from for that section. It comes back through the hole that I showed you into my power supply board. And this power supply board is one that I purchased, and it puts out 4 different voltages. I think I talked about this before in the prior video. 3.3, 5 volts, a 12 volt, and a variable voltage. The variable voltage I'm using for my servos. And the 12 volts, I've modified this board so that I actually get the raw 12 volts from the battery through a 1/4 amp self-resetting fuse. So I've removed the regulators that were there because they wouldn't regulate properly anyway, because the 12 volts coming in would be too low for that. So this way I have a tap from the battery that's protected by a low amp fuse for whatever I decide to use it for. Right now I'm not using it for anything, so there's no wires in there, but something may come up later on. So you can see the layout works out really well. Now I have 2 boards on here that I made myself. This one is simply a board that converts these motor connectors to screw terminals. So I just wanted to do that so that if I want to change these motors, I can simply unplug them, put a different motor in there, and plug it right back in. So these, I believe, are 50 RPM motors. And my concern was that that might be a little slow. I don't know, it might be a little worked out just fine. But if I decide I want to put maybe a 100 RPM motor in there, all I got to do is unplug it, plug the new motor in, and away I go. So that was a little board I made, and it simply runs underneath. The wires just run from those pins over to these screw terminals so that I can just easily wire it and not have to unsolder anything. Now, I haven't run the power wires yet. They will go from here to these posts for the output of the motor driver. All of the low voltage power has been run from our power supply board, so like 5 volts, comes over to my power distribution board here, and then gets split on these yellow wires to all the different points that need 5 volts. I've got power wires running up to my 2 processor boards, and that's the nice thing about using this DC distribution board is I have lots of different points to tie to. The relay board is being used for 2 things. One relay is being used to switch the 12 volts to my motor drivers, and the other relay is being used to switch the voltage that will eventually go to my servo controller board, which I don't have here yet. I haven't placed that board yet because I want to wait to see what that's going to be used for and put that close to wherever the servos are going to be, because a lot of times the servos don't have really long cables on them. Just save me from having to extend those. So I will have a servo driver board of some sort at some point, and I'll mount it, and then it will get its power from this relay, and that will allow the processor to switch the servos off if I'm not using them. So if I have servos doing something, could be a robotic arm, and I'm just navigating and traveling to a different location, but I'm not actually using the arm, I'll be able to park the arm, and the processor will be able to open this relay and shut down the power to the servos, conserving the battery power. The motor driver relay, similar idea, is that if I'm not going anywhere, if I'm not traveling anywhere, I can, and I'm just stationary, maybe I've got a camera, I'm watching something. Well, while I'm sitting there watching something, I can shut down the power to the motor drivers, again, saving battery power. So the relay board allows me to switch things on and off to save energy, and if something were to happen with the motors and they were to take off, and I could have a way of shutting them down. Good. The other board that I created is something I mentioned in a previous video, and this is just a little surge protector between the control signals from my motor drivers, and they will eventually be wired into my Arduino here. So I haven't completed the wiring. There's no wires here yet because I have to decide which pins they're going to go to. But these go down in from my motor driver inputs to the little surge protectors, and then over to the control pins that I'm going to use on the Arduino. And as discussed in another video, this is simply a 100 ohm resistor and a Transorb diode to absorb any spikes that may come back from the motor driver, protecting my processor. So those are the 2 boards that I made. They're very simple boards. This one looks a little more complicated only because I put some LEDs on there. You know, you gotta have LEDs on everything. So as you can see, I have all of my 5 volts on these yellow wires coming from my DC distribution. I have my variable power going through this relay, which is going to be set for 6 volts for my servos. I have a 3.3 volts here. So far I don't have anything on this build that uses 3.3, but it's there if I need it. And the other thing I want to talk about is that I'm running everything off of these power supplies, and I'm not using the inputs to the boards here that you typically might use for an Arduino. I could have, so you could take a cable like this, and I could have just plugged this in here, and I could have run it, say, to that 12 volts there, and that would be perfectly fine. So why wouldn't I do that? The reason I don't do that on this build is because the regulators on the Arduinos are linear regulators, and they're not very efficient compared to our switching regulator down here. So since this is a battery powered application, I want everything to be as efficient as possible. So I really don't want to use these if I don't have to. So the idea is that I'm taking this 5 volts through a very efficient switching regulator, takes that 12 volts, converts it to 5 volts, and then through my distribution board goes off to my 2 processors, and it goes into the 5 volt pin that is on my processor board. So now both my Arduinos are being powered by a very efficient 5-volt source. I'm not wasting power in these linear regulators. The other thing to notice too is my little connectors that I make, similar to what we have over here. Now this is something I bought. These screw terminals just plug into the Arduino. They fasten on with these little standoffs and bolts. I can't pull it out to show you, but they're really nice because you can just screw in and out, move the wires anywhere you want. A lot easier than soldering things. So I like those. I didn't find one for the Mega, so I decided to kind of make my own. And what I've done here is I've just taken your typical pin header, standard pin header here, and soldered it to a little screw terminal connector that I bought. So I basically made my own screw terminal conversion, so then I can plug that in, and now I can just put those wires in and out very easily. These two wires happen to be the power for this board. On these other boards, I've also made my own connectors. In this case, what I've done is I've soldered socket headers rather than pin headers. So this is the female version of the pin headers. You probably have these, but you may not have these socket type. And that makes for a really nice connection. So when I'm plugging in my relay board, I can simply just plug that in. Now this is simply wires soldered to those pins. Here's an example of one without the wires on it. I've got a couple different types. This one is made to be snapped into different lengths, and this one is purchased at a predetermined length. Either one could be used. You can cut these. If you're willing to sacrifice a pin in the middle, you can cut them. Usually I just snip them apart with these, and that works fine. So if you can buy these in a longer length and you cut them down, or you can buy these ones that snap apart. And just solder the wires on, a little shrink tubing, and you got yourself a really nice connector that just plugs right into the board. So if you ever have to make any changes, or you want to pull that board out for any reason, makes it real easy, makes nice clean connections. And that is as opposed to using this type of connections. You've all used these. These are very popular. But these are not real permanent. And so I don't like to use these on this type of build. These are made to plug right in here. And then I could have run those over to my boards. But if I'm going to build something custom like this, and I want the wires to all be laid exactly right, I want them to be all the right length. And so I'm just going to make my own little connections on each end. This is fine for prototyping on a breadboard, but when you're building a chassis like this, it's nice to go the extra mile and make everything fit right with the nice permanent connectors. So a couple more things I want to show you. One is how the battery mounts in here, and I did have to make a little bit of a modification on this chassis. Now this is one of my own chassis, and normally I just strap the battery in here with these Velcro straps, and it works very well. You can see how well that holds that. It doesn't go anywhere. I want to show you, I'm going to take this out real quick and show you what I had to do, and the reason I had to do it. Take the battery out. Now the reason I'm showing you this is because it's not normally part of this chassis. These rails that I put down here, a lot of times I use motors that don't have encoders, and I don't really have to worry about if the battery were to slide over and butt up against that. But in this case, I'm using motors with encoders on the end here, and I had to make sure the battery wasn't going to slide into that and cause a problem while it was running. So I took some more of this railing and I cut it and I screwed it down into that position, and so that way when I put the battery in here, it will not slide around and keeps it perfectly where it's supposed to be. The other thing I wanted to show you is I added these two standoffs, and those are in some pre-drilled holes in this chassis. I added a couple more down here, and I made a nice little protective window for this. Now this is mainly just protective to keep things from falling into the power bay. You could make this out of a more solid material. and you'd have all of this space up here to mount anything up here you wanted. Could be a LiDAR detector, could be a robotic arm, but that's the nice thing about this chassis. It has these points where you can put these standoffs and have another platform here. So I'll get the battery connected back up here, and the last thing I want to mention is you can see I still have space left here, and of course we're going to be adding sensors, and I don't know what else, but this is the second part of this series showing how I laid in all these boards and wired it all up. In the future we'll have who knows what here, but that's the whole idea of starting out with this whole base like it is. So that's it for this video. Hopefully there'll be a part 3, and I'll show you what I do with the rest of the chassis, put the wheels on and some sensors, and maybe we'll have an actual robot roving around on the ground. We'll see what it does. I want to mention that the chassis is available on our website, and I also want to let you know that the address of our website has changed. We are now at robertsrobotics.com. So thank you for watching this video, and we'll see you next time.